And coming next is our fourth keynote sharing. In this session, Mr. Alex Ng, CEO and Technical Consultant, BBAST Technology Limited, will outline the main elements needed to achieve the humanification of Industry 4.0. Mr. Ng, please.
Okay, I'm a Hong Kong citizen, and I take this opportunity to thank HKBC have this very giant, very good digital economics summit. Yeah, and thank you everybody come here today. Okay, today I will talk about the humanification of Industry 4.0, just a simple review of all the technology page. Okay. Okay. Actually, the technologies, after reviewed, we have creation of technology and technology realization and the technology deployment and the technology application. The most important is the technology who created human being. And how to realize is the touchable and the sensible. And deploy, how to deploy. So everyone will learn technology very easier. And how about the application? All right. And then the first creation of technology, it is originated by human being. And from thousands of years ago, you know, the ancient people will use stone as the tool for earn a living and then fight for the beasts. And secondly, when coming to the farming stage, the farmers use the plow, harrow, and then after this age, and then there comes to the first industrial revolution stage. So the first knitting machines, what we call machinery stage, okay? But nowadays, what we're talking about? We're talking about the network, big data, AI, VR, and the metaverse, something like that, and the body of execution, what we call intelligent robots. And the technology realizations mainly depends on the execution of the body, what we call the robots and the peripherals accessories. And how about the brain? The brains, what we have is the simulation software tools, for example, artificial intelligence, visual reality, VR, and the metaverse. One now, which is a very hot topic of the metaverse. And by mixture of the big data, like SCADA, and the SCADA meaning the interface between the front-end body to the upper like MES and the ERP inside a factory, very big enterprise. And how about the digital factory right now, or digital twin? We are very, very hot topic in the existing world. And the above elements form an industry 4.0 and realize technology and become human and layman, touchable and sensible. Yeah. And how to deploy? This is the very important things. After create something, we need to use as a tool, help us to make things much more efficiency, right? Just like your mobile phone is iPhone is using the iOS system, operating system, and Android using the Android operating system. Then you can play Facebook, you can install WeChat, and you can install blah, 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 too many tools. And then creating the technology application platform for laymen. Platform is very important because the professional guys already have the idea and have professional expertise to create a platform for layman use. How to make everything down to the layman level? We just make the technologies touchable and sensible and interesting to the human life, which is very important. And making the technology not horrible, not noble, but respectable. Just like doing the ping pong, something like that, yeah. And so we can make the technology interesting, okay? Merge together in your life, yeah. Okay. And how to apply, in what way and how? First of all, we think about technologies can create just a human-like, the body is the hardware, and the software, the brain, okay? The body includes the intelligence robot system. What is the definition of intelligent? And we will discuss later on. And including also have a AGV, you have seen it before. Even if you're in the restaurant, you can see the robot traveling around and then taking some dishes for you, right? And then the computerization, the logical thinking hardware by making use of some controllers and the server for database storage. And the software is the brain. Think about the logical thinking and then control programs. Data manipulation, yeah. And including right now, very popular is the artificial intelligence and the virtual reality and the digital factory and even now, metaverse. So we can shortly review the industry places from 1.0 to 4.0. And you can see in this, in year 1784, this is the first lithium machines that happened in the world. Yeah, so what we call is a mechanization. And then after 1 century, and it becomes a production line concept. That means there's a troop of people in the production line sitting here, right here to produce something, and then the job classification and job divided into piece by piece and link up together. This is the production line concept. And then after another century, automation becomes very popular. Now, and in 1969, the first programmable logic controller, that means is the hardware of the brain, appeared, all right? And then until now, is what we're talking about is Industrial 4.0 revolution. That is intelligence. And we can separate the investment of human to the world to assess and to achieve the Industrial 4.0 by 8 sectors. The first one we can see in big data, digital factory, robot body, robot components, sensors, automation, network, safety, and IoT, yeah. Someone all of us may know IoT, right? Okay, so when we compete, we want to achieve something, okay? Or we want to have a plan to make a factory or make some project. We need to fall within the PDCA progress to make the thing success. P is stand for plan, and then D is stand for do, and the C is checking, and the A is the action. Take the action if after the checking with some error or some deviation, we need to take action. How? Because we have the server and we have the digital system, then we can retrieve historical data and check about the progress and whether it's a deviation from our desired targets. So this is the digital factory. Actually, it's right now become a very hot topic, and the digital twin. Yep. So we can make use of the advanced software tools, right? And then this one actually is a digital factory's software. And then before any action, we need to plan. And then plan how to do, right? So this is the project, and then you can see the factories and with a list of how to arrange the robot system and then how to integrate the warehouse system, and then how to integrate the AGV system. So after calculation by this software, and then we can utilize all the resources and then make things much more efficiency. Besides this, we have the global system, just like the cloud system and the server system, and then we'll check about what our performance and what we do. Yeah. Even we can globally, all around the world, to share the information with the customer or to share the information, the performance of the material supplier all over the world by making use of the cloud system or internet. Yeah. And the intelligent robot, what we call previously, is consists of the body and the brain, just like the human being shown right here. So the brain can learn, the robot can tactile and the visual. So we need to have some critical components to make him success. What's the intelligent definition? Which is the industrial robots, tactile force, just like a human being can sense something, right? And then the execute, and then the adaptive and the self-learning capabilities, right? And then can adapt to environment by choosing programming, and automatically complete more complicated tasks according to some programmed route. Just like the first Professor Lee had displayed some fantastic sensors embedded in the robot. So we can see we can have another very critical vision, machine vision. It's a very critical part for the robot. And you can see the color recognition by making use of 2D camera. And then the 3D laser vision can check about the profile of the object, and you can use this object's profile and then embed it to the control system and the logical system, all automatically. Yeah, and also the robot can make sure of the machine visions to pick up from the chaotic supply materials, which is disordered. And the force sensor is very important to sense everything. This is one of the very critical components inside the intelligent robot. So it can sense in different directions for the force applied to the robot, and so such that it can perform series of different job natures, such as, for example, the polishing, the assembly, very high precision assembly job. And then you can see, just like the first speaker's Professor Lee, yeah, that's have a self-learning, and then after learned by the human being, he will perform the gesture and the job by itself. Yeah. And the most important is this can be integrated with some software construction tool, just like SolidWorks, AutoCAD, and then after this, and then you can make sure of the robot's simulation software to program offline. I would like to take this opportunity to to talk about the Fennet robot arm family. I have a story before, because I already take part in the automation projects for more than 20 years in electronic markets and in parcel market and metal market. Yeah. So I can just take a look at the 6-axis robot. This is the traditional robot used in industry and the commercial. The first one is the 6-axis robot. The second one is the Scala robot. 6-axis robot and Scala robot is very frequently used in the market, especially in the industrial application. And the spider robot, which is fast enough for the medicine and some food market. And the co-robots right now have become very popular and very advanced because it has the sensors distributed all over the body of the robot, such that the co-robot can do the job of 80% of the human being, and another 20% or 10% are carried out by the human being. You know why I have been interested in talking about the family robot, but I'm not helping them to do any advertisements. Okay, and actually, this is my real experience. And then 10 years before, one of my customers come to my factories and discuss with me. Again, at that moment, I'm the first time to touch with the robot, and then they told me that I have a 12 very old robots in my warehouse and already idle for 5 years. And it's covered with the dust. I don't know whether it can be reloaded and reused again or not. And then after I go to the warehouse and take a look on the metal plates, declare the factory outputs date is 1996. This scared me too much. However, when I try to work together with a vendor's company for almost 2 months, when we plug in the power and then you work again, it's just like the movie of the real steel. There's a rubbish training robot that can be realized by the children, right? By the child, yeah. Well, now the robots have become such very beautiful and slim, yeah. And then you can see this robot, after I make this alive, okay, and then it's become also very high precision and the speed is very good, yeah. Okay, and then after this, I have a bet with my customer. So long as I make use of your very old, 30 years before robots, I can doing some job for grinding, then you have to put me the PO, and then finally, when we success in the center part, you can see the video, all right, performing the job very well, right? And then finally, he asked me to help them improve all the grinding process in there. This is actually is the notebook cover. The material is made by the magnesium alloy. And we can compare with existing the robot performance, something like this, right? You can see which is a very high speed and a high precision and a high technological communication, all right? It can be communicated with internet and LAN. Okay. And this is the actual application in the industry, very popular, so used in industry. And then you can see on the left-hand side of the video, there's the robots integrate together with the 3D camera, can check the profile of each different soup and then performing the growing process. And the right-hand side of the videos, you can see the green color. Okay, the green color means save the planet and human friendship. So when you touch it for safety purpose, it will stop, pause for a few seconds. This is for safety purpose. And right now, you can see that that's very popular in the application of the robot, not limited to industry. Industrial enterprise, no limitation. Also, you apply it in the commercial world. And then you can see on the right-hand side making a noodles. Yeah. Actually, this one is a canteen of the vendor's headquarters. Yeah. And another one is I make the golden rings polishing in 10 years before. Yeah. So you can see very high precision, very fine-tuned job. It can carry out to replace one master of polishing. One master of polishing, how long it had to be tuned up? At least 2 years. So this is very difficult to find a human being, find a master of polishing to carry out the job in existing world and nowadays. Okay. Besides this, we can also use the 6-axis robot for packing. You can see the chocolates with different shape, maybe triangular shape, circular shape, oval shape, yeah. So every different shape can be matched together with the 2D camera and then picked to the desired packagings. Yeah. And this one is the Scarrow robot, which is a very popular found in the industry for light industry, especially for electronic field. And because of it, the coverage of the range, the radius is very wide, and the speed is very fast, and together with many robots work together. Yeah. So you can find the first robotic arm is doing the screwing job, and the second is for the gluing job, and the third one is for the testing, and the last one is for label sticking on the PCBA. Yeah. And spider robot is also is very popular in the light industry. For example, also for medicine, semiconductor, you can find it here, and even you can use it also in the package. Yeah. Someone will ask me, can I use a tailor-made automation line to replace the robot? Yes, but provided that the PO quantity of the manufacturing quantity is very huge, just like 1 million per month or 1 million per 2 months, something like that. But now, because of the climate change in the economic market, many enterprises will have a very short PO quantity, just like maybe 1,000 or sometimes maybe it's a few hundred. Yeah. So the changeover is too frequent. It's better to use the robotics mechanism to help the industry to provide a flexible changeover for the jig and fixture and different fulfill the different model types.
Somatic is an autonomous robot.
So you can see that right now in the commercials, we can use, especially in the COVID-19 2 years, 1 year before, right? We can use a robotic to cleaning and doing some cleaning job in the toilets or in any other dirty environments. And you can see the robot, it has a very fantastic self-learning mode, just like you can see in the first Professor Lee's presentation before. Yeah. And what I introduced to you before is the robotic arm for co-robot. Right now it becomes a very popular object, tools applied in the industry. It can take the job of almost 80% of the human being. And remaining the under 10%, the another 10% or 20%, that's a human being to help. Yeah. So you can see ironing of the seat. This is a car seat auto manufacturing. Yeah. This is the production line happened in China somewhere. Yeah. And you can see, yeah. Actually, it's, at that moment, the robots for example, is more than 260 models in existing industries environments. And even those robots can produce robot itself. Something like, you can see the robot, can manufacture the robot. Yeah. Down from the component level to the complete set. Okay, all through auto. So you can see the CNC machines, and then every single part. There's absolutely you cannot see any one of the worker in the manufacturing field. Okay. Okay, this is actually, so we can also have, just like I introduced before for the Scarab robot, to cooperate with different robots together. And every robot can also doing the same job. For example, the 6-axis robot, spider robot, Scarab robot, and the co-robot. And we can also use the VR. In the coming days, there will be many applications for the VR. That is related to the first, at the very beginning, I talked about the technology deployment to the layman. For example, someone will not know the mechanism, the professionals of the robot, but you can make sure of this platform to do some decided job and then to complete some tasks. Finally, is how to check about the deviation and the error. Okay, so we can have, there's a data flows for the whole factories. We can have the body, okay, of the robots that execute a certain kind of jobs and tasks. And then after this, there will be a monitor system by the upper level of the server. And then the server will check about if everything's happened in the, for example, the factories or in the restaurant, all right? The robot, the hardware, they execute very well, or is there any error happen? Then it will, at the same time, will transmit all the information to the boss of the factory or the management of the factory. Okay. And how about Hong Kong industrialization? As at the very beginning, I introduced myself as a Hong Kong citizen, and then I come across 30 years. I think I from the student's age. I went to the factory and then doing some summer job, and then there's many kinds of jobs that I can take. So, but until now, we can't see anything in the factory. But some day, some nights, I think about whether Hong Kong can be making some high-grade food or medicine automation, just like this medicine are very popular. Yeah, we can take Japan's Hokkaido's white lover theme parks as an example. Yeah, they're making the biscuits full automation, and the yearly turnover, just a very small page, is more than 1.2 billion Hong Kong dollars. This is the white lovers. And then this is the car store, and a very beautiful place, but small enough, just like this area. Yeah. And then actually, I like Kei Wah Bian Gai much more for the egg rolls. Yeah. And actually, how about Hong Kong if we create white dolphin love biscuits? Yeah. You know, Chinese white dolphin always appear in Hong Kong water sea. Yeah. So one of my minds as a country is making the white dolphin love biscuits. Yeah. And the future developments of the technology. So you can see everything can be automation. That's all my presentation. Thank you very much.